So in this section we're looking at trig functions at any angle, and we've already discussed our 6 different trig functions that we have: sine, cosine, tangent, cosecant, secant, and cotangent, and the various rules in relation to the opposite, the adjacent, and the hypotenuse sides. And if we take a look at any triangle here, we always have an angle that we're going to be theta, looking here, and we could have the opposite, the adjacent values be the y and the x respectively, and the hypotenuse is r. And we have some common ones that show up that we may remember from geometry. The one on the left is our 30, 60, 90. And in that 30, 60, 90, we have the relationship of the shorter leg to the longer leg is a to 2a. So let's say the shorter leg is 1, the longer leg would be 2. Or the hypotenuse would be 2. The shorter leg to the longer leg, if it was 1, it would be root 3. So we could even think of 1, 2, and root 3 as being that relationship. Now this is just the similarity that they have between them. If I change the values and make them a lot bigger and a lot smaller, they're still reduced down to that 1, 2, root 3 idea. Same side on the 45, 45, 90. If the legs are both 1, the hypotenuse would be root 2. So we're going to use that to help us today. Now we've talked about the unit circle, and we've made those values half of them because the radius need to be 1. Or at least for the 30, 60, 90. But now if we just keep that ratio present, it might help us as we go through them a little bit more. We also have to keep in mind we'll have quadrants. So our quadrants are 1 through 4. And if we think of the x and y values in each quadrant, the x and y is positive in quadrant 1. In quadrant 2, we have a negative x and a positive y. Quadrant 3, they're both negative. And in quadrant 4, the x is positive and the y is negative. And we can take this idea, and going back to what we did with our sine, cosine, tangent ratios in relation to y, x, and r, and we can start to see that sine, cosine, and tangent would always be positive in quadrant 1. If we went over to quadrant 2, because cosine is the adjacent over the hypotenuse, it would be a negative x value, so the cosine value is always negative in quadrant 2. Same thing with tangent, because it's negative x over a positive y, would be a negative value as well. Sine would be positive because your y value is still a positive value. Going down to quadrant 3, we get that sine and cosine are both negative because it's going to be a negative value over the hypotenuse. And then tangent would be positive because it's going to be a negative over a negative, being your negative y over your negative x. Quadrant 4, we now have a negative y value. That results in a negative sine, a positive cosine, and a negative tangent. Now keep in mind the reciprocals of those, cosecant, secant, and cotangent, would all be the same sign as their reciprocal, so we don't really necessarily need to list those. So we take that along with this idea of ratios and we start to think about reference angles, because we're going to get different theta measurements, whether they're radian or degree mode, and what we need to be able to do is create the triangles from those angles. And it's not that we're going to take the theta itself and use it, but we need to apply, depending on what quadrant it is, to what triangle it makes. Now, for example, if we start in quadrant 1, this triangle here, okay, I'm just going to drop down a vertical side. I'm going to create the right triangle, and I'll treat it the same way. But if I'm over in quadrant 2, I'm going to drop the horizontal side down, and I actually have a reflection of that triangle that's in quadrant 1. And the theta that gets us there isn't the angle we're actually going to use. What we want is the actual supplement to it. The supplement to it will create that right triangle. Now we could think of it as 180 degrees minus theta if it's in degree mode, or pi minus theta if it's in radian mode. If I'm in quadrant 3, that means I've gone past 180 degrees, and I now have our triangle facing down. I want to find that degrees or that radians that's after the 180. So if I'm after 180, what's left over? For example, 210 degrees. Let's say that was theta. Well, that's more than 180. If I subtract 180 from it, I have 30 degrees left over on the other end. And then we go over to quadrant 4, and now that last angle that we're going to use after we've taken our theta is going to be what's left to get us to 360, or what's left to get us to 2 pi. So it's that difference, that remaining value that we have. So we've taken these theta values. We can now make a reference angle which now we can put in a quadrant and pay attention to the signs, which relates back to the trig ratios that we have. So we can kind of start piecing it all together. So really this process of evaluating trig functions of any angle is we're going to determine the function value of the reference angle. They're going to give us a degree or radian measure. We want to figure out what the reference angle is to go with that. And then depending on the quadrant, we've got to pay attention to our positives and negatives. So let's start with sine of 4 pi over 3. We'll get to the sine part of that, but more importantly, 4 pi over 3. If I'm comfortable with radians, I have the idea that 4 pi over 3 should be in quadrant 3. And that's because 3 pi over 3 is pi, and so I have a pi over 3 more than that. If you're not sure, then just convert it to degrees. If I convert this 4 pi over 3 to degrees, which means I multiply by 180 over pi, well, the pi's reduce out, and I get 240 degrees. Now, 240 degrees would be 180 plus 60. So really, I have this triangle here where the angle is 60 degrees for my reference angle, and I get it that 30, 60, 90. So when I have this triangle, I could go back to that unit circle and use those basic forms, but it's a 30, 60, 90. The ratio of the sides is always present. 60 is the larger of the two angles that are not the right angle, so I could put 30 right here. 1 is always opposite to 30. 2 is twice the shorter leg, or the hypotenuse, and then root 3. Now, just for the sake of avoiding getting confused, let's cut out the 30. So in this location, I actually have a negative x value, because going back up here, I had to go left and then down. And I have a negative y value. So in this triangle, I went back 1, down root 3, and then 2 is my hypotenuse. So to find sine of 4 pi over 3, which is opposite over hypotenuse, I'm going to use that 60 degree reference angle, and I get that 4 pi over 3 is negative root 3 over 2. Now, just to give us another idea, we could have done cosine. Cosine would have been negative 1/2 over 2 because it's the adjacent over the hypotenuse. Okay, well, let's look at another one, see if we can start to see the pattern developing here. If I had cosine of negative 60, that means my reference angle would be back 60 degrees in the negative direction. Okay, well, that actually gives us the reference triangle that we need, or the reference angle. So this is 60. My shorter leg is 1. That's going to be a positive 1 in the positive direction. 2 is the hypotenuse. Hypotenuse is always positive. Take a thought about that. X and y, those adjacent and opposite sides, are the x and y values for the coordinates. And those are the location on the graph. Whereas the hypotenuse we have to be careful because that's the distance it is from the center. So the center to the edge of the circle, also known as the radius. So that distance is always positive. Don't think of it as a slope or something like that. It is the length, so that's always positive. So, and then my last side is root 3, but it's negative root 3 because it's facing down. So, cosine of negative 60 is going to be the adjacent over the hypotenuse, and that's 1/2. Okay, last one here, tangent of 11 pi over 6. So again, we could always convert it back to degrees, and you'd be perfectly fine, and you can use it from there. But let's get ourselves more comfortable with radians and maybe take a little bit different approach. So if it's 11 pi over 6, I know that's past halfway in the circle, because halfway would be 6 pi over 6, or just pi. But the entire way around would be 12 pi over 6, because that would be 2 pi. Now if the entire way around is 12 pi, I'm starting 1 pi over 6 short of that in the negative direction. So I either went 11 pi over 6 all the way around, or I went negative pi over 6 in the negative direction. So let's think in degrees, how we convert that to degrees. Now if it's negative pi over 6, that's 30 degrees. So I can think of that as a negative 30 degrees that I went back from the initial initial side. If it's negative 30, then it's also 330 degrees to get there. So what this is really getting me at is now this is 30, 60, 90. I have a side of 1 here, but it's going down, so that's negative 1. 2 is my hypotenuse, and root 3 is my adjacent side. So tangent of 11 pi over 6 is going to be opposite, negative 1, over adjacent, root 3, and that simplifies to be negative root 3 over 3. Okay, now we go to another approach. So a little bit different information we're given. So we let theta be an angle in quadrant 3. So we know it's here. And that sine of theta is negative 5/13. So if I draw my triangle, let's kind of redraw it a little bigger. So I have theta here. We don't use theta, we'll just recognize that it's our angle, because it's more of a reference angle. So sine is negative 5/13. Now sine is opposite over hypotenuse. We know hypotenuse is always positive, so it needs to be negative 5 over 13. So negative 5 is opposite the angle, 13 is the hypotenuse. I don't know what the angle measurement is, and in fact I don't need it, because I can figure out what the other leg is, and that's good old Pythagorean theorem. We would say 13 squared equals 5 squared plus our unknown squared. This is a Pythagorean triple, which turns out to be 12. Now it's going to be negative because we are going in that negative direction to get there. So we've completed the sides, and again this is Pythagorean theorem. And now I need to find secant of theta. Now I still don't know what the angle measurement is, and again, I don't necessarily need it. So secant is the reciprocal of cosine, so that'll be hypotenuse over adjacent, which is 13 over negative 12, so we'll just make it negative 13/12. And tangent is opposite over adjacent, and that becomes negative 5 over negative 12, which is positive 5/12. Okay, we go look at our next one. So let theta be an angle such that sine is negative. Well, let's see. Sine is negative. They're not telling me what quadrant it is here, but if sine is opposite over hypotenuse, and that needs to be negative, where could that be? So my hypotenuse is going to be positive. What I'm more concerned about is finding when the opposite side is negative. And we know the opposite side is the y value. So the reference triangles that I form where the opposite is negative is either in quadrant 3 or 4. So I've at least cut it in half and narrowed down my options. Now if tangent theta is negative 15 over 8 and tangent is opposite over adjacent, that either means I have negative 15 over 8 or 15 over negative 8. So let's just put those in and see if they fit. So if it's opposite over adjacent, and I wrote negative 15 over 8 and negative 15 over 8, I can kind of see that the one in quadrant 3 is likely out. Because again, that's not a negative 8 that I need. So that's out. Now if I looked at negative or positive 15 over negative 8, that one's not going to work either, because if it's positive 15 in either of those scenarios, it's not when sine is negative. So we're going to stick with quadrant 4. Now I can use Pythagorean theorem again and do 15 squared plus 8 squared, and this comes out to be 17 squared. So now I can do cosine theta is, here's our reference angle, cosine is adjacent over hypotenuse, so that's 8 over 17, and cosecant, which is the reciprocal of sine, is hypotenuse over opposite, so that'd be 17 over negative 15, or negative 17/15. So now we're given a function, given a quadrant, we need to try the trig value. So we know we're in quadrant 4, and sine is negative 3/5. Sine is opposite over hypotenuse, so our hypotenuse has to be 5. Our opposite is negative 3. Pythagorean theorem, we get a 4. for our adjacent leg. And then we get cosine is adjacent over hypotenuse, so that's 4/5. For the next one, we have quadrant 4, and cosecant is the inverse of sine, not the inverse, but the reciprocal of sine, so that's hypotenuse over opposite, and it needs to be -2/1. Well, there's an issue there. It's not going to be -2/1. It will likely be 2/-1 because our hypotenuse has to be positive and our opposite has to be -1. Okay, so that fits even in the diagram because the y value is negative. So now we can do Pythagorean theorem. We get 2 squared equals -1 squared plus, we'll just say x squared. We get 4 equals 1 plus x squared, and it turns out that x is going to be √3. This is probably a 30, 60, 90 triangle, but we don't necessarily need that for this part. Cotangent is going to be adjacent over opposite, which turns out to be -√3. Last one we have here is quadrant 3, and secant is -9/4. Secant is the reciprocal of cosine, so that's hypotenuse over adjacent. So I have 9 is my hypotenuse, and my adjacent will probably need to be -4, because again, the hypotenuse is not going to be negative. So I need to find the other leg, because I need to do tangent. So we'll do 9 squared equals -4 squared plus y squared. That's what we're looking for. 81 equals 16 plus y squared. We get 65 equals y squared, so y is the square root of 65. So then tangent becomes opposite over adjacent, not 64, it needs to be 65. So that's square root of 65 over -4, or -√65/4. So similar problem as the one we just had. Now we're looking at, we need to find cosecant of theta when it's -3/2, and then tangent is negative. Let's start there. If tangent is negative, its opposite over adjacent needs to be negative. So that means either the opposite or the adjacent is negative, but not both. Because if both were, then it would be positive. So when is just the opposite or the adjacent negative? We have in quadrant 4 and quadrant 2. So either of those could be our options. Now we also have that cosecant, which is the reciprocal of sine, is -3/2. Sine is hypotenuse over opposite, or cosecant is hypotenuse over opposite. Now it's not going to be -3/2, it's going to be 3/-2, because of course hypotenuse is always positive. So we take that information and compare it with our current options of quadrant 2 and 4. Now the 3 in both is the hypotenuse, and that's the same, but the opposite value only works in one of them. It doesn't work in quadrant 2. So it looks like it's going to be quadrant 4. Now I need to find my x value, my adjacent side. 3 squared equals -2 squared plus x squared. 9 equals 4 plus x squared, and I get that x is √5. And then I need to find the remaining trig functions. So what do I got so far? I got cosecant and tangent. Well, I got cosecant. Sine of theta is going to be opposite over hypotenuse. Its reciprocal, cosecant, -3/2. Hey, it matches. They are reciprocals. Cosine theta is going to be adjacent over hypotenuse, √5/3. Secant, its reciprocal, is going to be 3/√5, which is 3√5/5. Tangent is going to be -2/√5, which becomes negative 2 root 5 over 5, which is negative, which was a condition we had in the beginning. And then cotangent is going to be, we're just going to take the first reciprocal we had for tangent, and that's going to be negative root 5 over 2. Okay, so now in this last set, we need to find two solutions to the equation. Notice we're kind of taking the information we had on the last problem and we're not giving it a restriction. We're not saying, oh, something has to be negative or positive or a quadrant. We're seeing what are all the options we have. So if I'm looking at secant of negative 2 root 3 over 3, where could I go with this? So secant is the reciprocal of cosine, and cosine is hypotenuse over adjacent. So our answer is going to be actually when we have 2 root 3 over negative 3. So where could that work? If we think unit circle here, when could I have a negative adjacent? Well, that means it's going to have to be over to the left side, and we'd be here, because I'd have negative 3, 2 root 3, 2 root 3. So we need to take, if we're not recognizing the values yet, and maybe use Pythagorean theorem to help us out from there. So I have 2 root 3, negative 3, and my unknown. 2 root 3 squared equals negative 3 squared plus y squared. I get 4 times 3, which is 12, equals, we got 9 plus y squared. And then we go subtract, we get 3 equals y squared, so y is root 3 right here. So what type of triangle is that? Well, it looks like the parts of a 30, 60, 90, but we have some issues here. This is not my shorter leg, that's actually my longer leg, because root 3 is my shorter. Let's draw it a little more appropriately here. Root 3 is my shorter leg because my hypotenuse is twice that, and then this is my longer leg, which is root 3 times root 3. So this means this is 30 degrees. So it's 30 degrees, so I take 180 minus 30, and I have 150 degrees. And then for the bottom side, it would be 180 plus 30 degrees, and it would be 210. And I could then convert both of those to radians if needed. Okay, now if we look at cotangent being negative root 3. Cotangent, let's see, cotangent is adjacent over opposite. So if it's negative root 3, it could be negative root 3 over 1, or root 3 over negative 1. So where could that be adjacent and opposite? So if it's negative root 3 over 1, it'd be here. And root 3 over negative 1, it would be there. So what are those values? If I have our adjacent is always the root 3. There's my opposite. This one's actually looking a lot like what the parts we had for the one above it. In secant, when it was in quadrant 3, it kind of followed the same pattern, which means this is 30 degrees, so our first angle will be 150. But then we're in quadrant 4, and we have a 30-degree reference angle, so that'd be 360 minus 30, so that'd be 330. Now, cosine of theta is negative 1/2. Cosine is adjacent over hypotenuse, so that needs to be negative 1/2. When would we have adjacent negative and hypotenuse positive? So we'll go to that side. We have negative 1 and 2 to both of those. Now, we recognize the 30, 60, 90. This is root 3. This is negative root 3. So in this case, the 60 degrees is the reference angles. So I have 120 degrees, and then 180 plus 120 degrees, which is 240 degrees. Last one, secant theta. Secant is the reciprocal of cosine, which is a hypotenuse over adjacent. So that's root 2 over 1. When could we have that? Well, let's see, positive adjacent could be there. Or it could be down here. I have 1 and root 2, also down here, and this is be negative 1, positive 1. We should recognize that one as 45 degrees, or 45 from 360, which is 335 degrees. Now, these are a little bit more of a stretch on the ends, but it's good if you're able to work your way backwards to those and start to recognize where those special triangles do show up. There's your daily homework. Good luck.